So what we're going to do is talk about the building thermal envelope in this section of the code. And as we said, remember that you really kind of have two commercial energy codes here. You have Chapter 5, where you have ASHRAE 90.1. Most of our presentation is probably going to focus a little bit around 90.1, but whenever there's a difference, we'll try to point it out, a significant difference. Say, well, this is how Chapter 5 does it a little bit. We're going to focus on ASHRAE. The big things are insulation, air leakage, and fenestration. Brandon?
Climate zone map. So you'll find this in ASHRAE. You'll find this in the IECC 2009. This sort of tells you what tables to use. And if you'll see Georgia, we're actually sort of an interesting state. We've got climate zone 2 down here, sort of in the coastal region. We've got climate zone 3. And then we've got climate zone 4. There's also this thing called the warm humid line, which really doesn't show up much in the code, but we call it sort of the gnat line. You know, if you get below that, you're going to have gnats. It's that and the other. And then you also see this. We've got moist, dry, and then marine. So we're actually currently, today, we're in climate zone 3A. And the code reflects that. So again, yeah, Georgia has 3 climate zones, and we're going to start looking at the various components. R values is what we're going to be talking about. Is everybody familiar with R? R values? What does that stand for? What's R stand for? Resistance. So yeah, how well does a material resist conduction? Again, we're going back to our building science stuff. What about U values? What is that? It's the reciprocal. It's the inverse. So R value equals 1 over U. Conversely, U equals 1 over R. Now, they use R values, this resistance, they use this really for materials or components. So a piece of insulation will have an R value. It will be able to resist conduction by X amount. They use U factors or U values for assembly. So we'll take a look at a window. You know, it's multiple components. They do not talk about R values. They talk about U values.
I think that, yeah, that's probably, you know, you're like, why can't we just have one? But at the end of the day, the code will typically give you, you'll see in the prescriptive code, it'll give you an R value for, you know, the wall insulation bat, for example. Or it says you can build an assembly that has a U factor that's no worse than this. So we want a high R value, we want a low U factor, right? The lower the U factor, the less the conductance through the material.
Yep.
Metal buildings, Butler buildings. You know what I'm talking about? Metal buildings, I finally come up with my definition. Metal buildings basically have their own code. They have their own code. That's the simple way I can describe it. The metal buildings just kind of have their own set of rules. And they're probably at the end of the day not that big a deal, because if you think about it, a metal building, while it does have some compression of the fiberglass. Where do you see the fiberglass getting compressed in a metal building? At the purlins, right? And the code does have some requirements that you have to have some blocks, thermal blocks, to kind of minimize this conduction effect to some effect. You know, if you really look at it, most metal buildings, do they tend to have a lot of windows in them? No, they tend to have very few windows in them. So as a result, probably they perform no worse than any other, you know, commercial building. And I think by virtue mainly of the fact they you don't typically see them with a lot of glass. But the bottom line is they kind of have their own code. Does anybody here build a lot of metal buildings? If you do, you do. That's right. Does anyone here sell metal buildings? I mean, tell us, is this a kind of an onerous thing in terms of, I don't think the code is really that much different for metal buildings. It just is different. Thermal blocks can what?
He's never used them.
Oh, you've never used them. Oh, then that is a big deal. Then that is a big deal. Yeah, and it's going to add to the cost because essentially when you compress that fiberglass right there at the purlin, you're getting very little, R value effectively. So the block is designed to handle that. And thank you for commenting on that. I'm glad I asked that question. But in general, the R value requirements, you're probably, R19 in the ceiling is not that hard, is it? Maybe it is. 3 inches of fiberglass? That's not going to get it.
Well, that's been what the minimum has been for years. It was 2 inches.
Okay.
It's 10 foot here.
And again, we're sort of talking over the
Glad we're
break.
having this discussion.
Depends on whether or not it's conditioned. If the space is not conditioned, it's not an issue. If it is conditioned or semi-conditioned, that's where you're going to start. The code will kick
Yeah.
in.
Yeah.
My experience has been, even if you say it's unconditioned, people don't want to be working in a shop on campus
Correct.
Sure.
in a hot box.
Yep. Yep.
With some insulation.
Yeah, and I think that's perfectly appropriate to give them some insulation, but you don't necessarily have to then bring it up to what we would consider a fully code compliant.
Condensate problem in the wintertime.
Correct. Right. So the insulation is going to help us on that front. But no, I'm glad you're here, and you're really the first person we've had that's been in our training so far that has really been able to speak from the industry side of things. Say what now? So at the end of the day, though, I want to make sure you know what the code is, and if someone's going to use this commercial building as a commercial building, meaning they are going to condition it, and it takes almost nothing in terms of supply air to basically kick you out of the semi-heated into the real conditioned space. If they put any kind of cooling in it or any kind of heating in it of significance, you're probably going to have to meet the code, in which case these rules do apply.
Well, the other thing too is even if you sell, if someone keeping the water from freezing, keeping plumbing from freezing, the other thing, which you run into, particularly where you're using for shops,
Uh-huh.
is in the wintertime, you wouldn't have more than 10 days in Augusta where you needed to heat them, but you do have to put heaters on them for about 10 days worth of heating and try to keep it from getting low by 55 or 60.
Well, if that's the case, then you're probably fully conditioning them. I mean, that's considered conditioned because it depends on the size. But remember that rule was 10 BTUs per square foot. If you can stay just under that, then you could go for the semi-heated route. But at the end of the day, you probably really ought to just say they're most likely going to be conditioned because that doesn't take much. I think you're going to find that a 50,000 BTU space heater on a 5,000 square foot building it probably would keep the pipes from freezing, but it would not keep the interior temperature at 55. I think there's no way that's going to happen. It's probably going to keep the interior temperature at 40 or something like that. So that's a design decision we have to make. But thank you, and I'm glad you're here to help educate us on this. But that's what the code says. Basically, and the walls are, I think, pretty easy. I think the walls are 13, if I remember right. I'll have to check. We'll get to the code in a second.
Yeah. Finally, if you're going to go the prescriptive or really the simple trade-off route, your building can have no more than 40% glazing as a percentage of the wall area. So if you're going to build a glass box, you're going to have to, we talked a little bit about this energy cost budget method, building simulation. You're going to have to go that route to show that you meet code. You can also have up to 5% skylights as a percentage of your roof area. So that if you're going to build a glass box building, you're going to get kicked out of the prescriptive code.
Don't do that. Don't build a glass box. So the other thing is that one thing that's really helpful for designers is that ASHRAE has some very good appendices. Appendix A in this has basically got tables and tables of just about any assembly that you can imagine as someone has already calculated the U factor and performance of it and R value. So you don't have to start from scratch on many, many things. And many of these tables are built into ComCheck as well. So if you just describe to ComCheck what you're building, it will come up with a U factor assembly. So very rarely are you going to have to kind of go back to the real air films and all this kind of stuff calculation. But those are factored in the code, as is the effect of thermal bridging. So we probably, well, I know I pulled it out. It's somewhere over here. We probably have all seen this in commercial construction, right? A steel stud. And, steel studs certainly have some good things going for them. They're straight, they don't burn, and we don't think the termites eat them yet. We're not sure yet. Some of those super termites might eat the steel, but not yet. But it's kind of amazing that if you can imagine, if I have a steel studded 16-inch on center 2x4 wall, and I put an R13 insulation bat in between the studs, do you think my wall is really acting like R13? Would you say it's a little bit worse or a lot worse than R13? Raise your hand. Okay, let's do a little survey. Raise your hand if you think the effective R value of this part of the wall with a 13 but 2x4 steel studs. Raise your hand if you think it's better than R10. No one raised their hand. Raise your hand if you think it's better than R9. R8. R8. Actually, it actually ends up as R6, believe it or not. Isn't it amazing? It's an R13 bat, but it's performing as an R6 because most of the cavity is truly an R13, but what is the R value of the steel stud? We like to say we'll round it up to 0, right? It's highly conductive. It's a thermal bridge. It's a super highway for heat to conduct across an assembly. So I will just say there are some folks in the design world that really believe that you should, if you have a steel assembly, steel stud, you should only put insulation outside of it. You shouldn't put anything in the cavity. And you could argue that's why I think metal buildings are better than steel stud buildings, because metal buildings they're not trying to imitate wood. And this is trying to imitate wood. Metal buildings, I think, do a lot better because they don't have all the framing 16-inch on center. So I think it's kind of an interesting effect. The main thing is that the code takes this into account. And there's a very significant change now that occurs in the prescriptive code for everybody in this room in Climate Zone 3. And that short answer is that when you have a steel stud wall, they want R4 foam board on the outside. Because the foam board creates a thermal break. Be it pink, blue, whatever, the foam board creates a thermal break, and that's what they're asking for. Now, you can put exterior gyp and cover it with foam board, but that's the prescriptive code. That is the second really big change in this version of the energy code. The roof going to R20 and the requirement for foam board on steel studs. Just letting that soak in, and no one looks happy about that news, but it's steel is great, but the Achilles heel of steel is that it's highly conductive. So this is attempting to deal with it. And like I said, some people really believe you shouldn't put anything in the cavity. You should just put only insulation on the outside. And that is an option, but that's not a requirement.
Let me ask you a question.
Please.
George and I do a lot of metal buildings that aren't really just metal buildings. I mean, they're commercial buildings, finished on the inside with just boards and all that sort of thing. I've got a system that I've been using that kind of, I think, takes care of that effect. But I am insulating the cavity instead of the outside. But I'm putting exterior gyp board on the outside of the metal studs, then interior gyp board on the inside. Because, you need to seal the cavity on the
Right. Well, I like that part.
Isn't that similar to what you're doing there?
Well, the only problem is, does anybody know what the R value of gyp board is? It's how thick is the gyp board on the outside?
Depends on whether it has to be rated or not. It's normally half inch.
Yeah, it's about a half an R value.
Okay,
It's not good is the problem.
Should I replace the gyp board with maybe, well, no, because if you've got you just have to bite the bullet. I mean, if you have to have a rated wall, it's got to be 5/8.
Yeah.
You're going to do better if you put that, if you use that, you could use the gyp board, the exterior gyp, in conjunction with some continuous insulation. Because the thing is like Mike was saying, you've just got a half inch. It's going to increase that, it's not an R6 anymore, but maybe it's an R6 and a half, so.
Exterior, if you put the metal building insulation outside of the gyp board, it's going to be squished all over. Just to get the girth, because your metal siding would go right up against the
And that's an interesting point, though, too. So we've had this previously discussions about metal buildings that are used sort of as commercial spaces, where instead of using just the metal building structure as you typically have it, you've got sort of this metal stud infill, which is actually going to kick it in to more of the non-metal building. It'll be considered it'll be a metal stud wall. So your insulation, you actually have to do more. Yes, sir.
One of the things, if you have put a metal building and use metal skin on the outside, and then you put a stud wall inside, you've got about an 8-inch air gap between
Yeah.
skin on the outside and the metal wall. So you really don't have that big a concern about the conductive value of the stud.
Well, it's about if your insulation is on the in other words, if your steel studs are just there, basically holding up drywall, then that's fine. But you've got to have insulation, in essence, between the skin. We have some pictures of this coming up, so. Yeah.
You don't have steel stud in contact with an extremely cold surface.
Right.
Hot surface.
Tell you what, let's go a little deeper because we've got some pictures that I think can work from, and let's also look at what the prescriptive code tells us for walls. So maybe just kind of hold on to that. I was teasing you. I probably teased you too much. But if you're just getting away from the metal building, if you're just doing we see a lot of this assembly, right? Just steel studs with exterior gyp. The code is very clear now in that situation. What they kind of want is something like this, where you've got your gyp, sure, if that's what you need for structure, or OSB or whatever sheathing, but you need to add the thermal break of foam board. Now, that can actually work for you if you stagger the seams of the foam board so they don't match up with the seams of the gyp. Then you can actually, that helps you from an air sealing standpoint. And the surface of foam board has a plastic skin on it, which can actually also act as a water shedding surface. And that can, in essence, if you tape the seams of that can actually be in lieu of house wrap, for example, or in lieu of a felt or a moisture shedding surface. So there are options out there. The other thing is, we talked about this some yesterday, this is a product called Thermoply and Energy Brace. And you don't see it as much in Georgia, but has anybody seen this before? It's used by production builders. Instead of OSB, they use this. And you have to staple it, a whole lot. But it's pretty thin. There's different thicknesses of it. But it's pretty thin stuff. And they make this product with a foam board attached to it already. And here's a couple samples. This is a 1-inch version. And they're using a polyiso foam board. So this is a rigid sheathing that also has insulation. And it's called SIS, S-I-S, Structural Insulated Sheathing. And an inch of this is an R5.5. A half inch of this is an R3. So there are ways of kind of doing this. And again, let me point out too that this is the prescriptive code we're getting across to you. There are opportunities to do trade-offs. So I'm teasing you probably more than I should at this point. All right, let's dive in and see a couple other things, and then we'll try to really answer some of these questions. So as we mentioned, the categories, non-residential is basically all commercial buildings. Brandon, one more time, residential.
Residential. So again, we've got, for multifamily low-rise, 3 stories and under, that is the residential code. If it's above 3, if it's 4 stories or more, multifamily, it's kicked in here. Also, other commercial spaces where people essentially stay overnight. So, fire station, dorms, prisons, frat houses. Those types of things are actually going to fall under the commercial code.
Okay, so everybody understand that that's got its own sort of set of rules. And then finally, the semi-heated thing, it typically has to be less than 10 in our climate zone more than 3.4 but less than 10, it's not conditioned. If the code official approves it, it can be considered semi-heated, but very few spaces are going to actually qualify as this. So I think we've covered this one pretty adequately. So again, the mandatory provisions of the code are insulation, fenestration, and air leakage. We'll probably do these in, I don't remember in the exact order. I think we come back to air leakage at the end. But in terms of insulation, these are sort of the correct practice rules. And the basic rule is you have to install insulation according to the manufacturer's instructions. And that means not compressing it and not leaving voids and so on. There is an exception to the compression thing for with thermal blocks in a metal building. It's the one exception to that. That's why I said they kind of have their own code. You have to install it correctly. The insulation always has to be in substantial contact with an air barrier. Okay? They have that one hard and fast rule. Vertically, really, you always want to have it fully encapsulated. So if a bat is your vertical insulation, you really want to have it front, back, top, bottom, left, right, fully encapsulated for it to work. But on a flat ceiling or a floor, you know, then it just basically has to be touching the air barrier. Try to imagine someone has a scissor truss, okay, and there's an attic space up there, and let's say that the truss is sloped like this in the inner cord here. Do you think that's a good candidate for blown insulation? What would happen if I tried to blow insulation right here? It would be kind of fun, right? So what they've said is you can only use loose fill if you're no more than a 312 slope. Kind of makes sense if you think about it. Otherwise, you're going to have to go to some other type of insulation. And then the big one here is recessed equipment. So if you have again, this is kind of more of a flat ceiling with insulation blown on top of it. If you have a flat ceiling with penetrations through it, it kills the effective R value. And so the energy code says, you know, that's a no-no, and anything more than 1% penetrations, you have to do something about it. So basically what they want you to use, for example, if you have a recessed light fixture, they want you, like we saw yesterday, to use the airtight IC-rated recessed light fixtures. The ones that are both airtight and that you can insulate on top of them. Insulation contact. Anything else big on this, Brandon? I'm just trying to hit the kind of the high points. A lot of these are just the kind of the rules you follow if this applies to your project. So let's take a look at the opaque part of the code, and so this is the chart.
Yeah, the envelope splits it up into opaque and fenestration. So it's going to, for all our opaque items, our elements are roofs, walls above grade, walls below grade, floors, slab on grade floors, and then opaque doors. A door, if it has more than 50% glazing, is considered fenestration. So, but if you have like a view light, that would be considered an opaque door. And you'll see there's essentially three columns here. We've got the non-residential, the vast majority of the commercial buildings we're going to be dealing with. We've got residential. Again, those are multi-family, 4 stories and above, anything where people sort of stay overnight. And then finally, the semi-heated space. And you'll see what they're asking for. They've got, hey, you can either look at it from an assembly perspective, a U value, a U factor, or you can look at it from just an insulation, how much insulation from an R value perspective.
I wanted to let you know, too, that these climate zone tables are in the very back of your book. You can pull it out if you want, or you can just look at what's here if you can read it. But this is you want to make sure you're in climate zone 3. We gave you 2, 3, and 4. So if you work elsewhere in our state, and you basically just follow the rules. I mean, this is it. This is the prescriptive energy code. We're going to make sure you understand all these values on here, that you know what it is. But this is basically the prescriptive code. Does anybody have questions so far? So you've got this entire table in the back. The top half of the tables, which is what you see up here, is the opaque part. The bottom part of the table is glazing. So, all right. So Brandon, let's focus mainly on this part, which I think is where most of our commercial buildings lie. So,
yeah, you can look. You've got sort of 3 conditions for roofs. Insulation entirely above deck needs to be an R20, and it's got CI. CI stands for continuous insulation. Metal building, R19. Attic and other, you need to have an R38 or greater. Actually, I wanted to skip back real quick. We were talking about sort of exceptions over the break, and I want your opinion on this, Mike.
I was going to mention.
Con has got a project where he's got an existing metal building or existing metal roof. They're not tearing it off. They're putting purlins on top of it and then coming over with a new roofing material. Would he have to insulate to code? So it's like we've got this roof up here and we've actually put purlins on top of it and come over with a new roofing material.
Why don't you ask me more questions in front of 40 people that I will look stupid about? Let me think.
Well, I didn't know, so I thought, yeah. So
it's up to the code official. That's my answer. I'm gonna say I got to noodle on that one a little bit. I did bring the ASHRAE also does put out a really nice document. It's like $75, which is still pretty cheap for ASHRAE, but it's a user's manual. So we'll take a look at that and we'll see if we can answer your question. So it's a good question.
I think maybe you don't have to. Would be my first answer, but it's a little unclear.
I was going to say that there might be some reasons why you would want to, but
yeah.
It's not
a good
100%
point.
clear why you want.
Well,
yeah,
I guess it
agree with
depends
that.
on whether or not you've got insulation under there already. So you have to bring it up to
that
that.
could be
Anyway,
a
sorry, I just wanted to
No,
bring that
I
up.
think,
So we still do not have a resolution.
We'll take a look at that. I think you would probably want to. I agree.
Moving on then, after roofs, we've got walls.
Wait a minute. Hold on a second.
Sure.
So I want to make sure that we really kind of remember these values. So probably the big number we want you to take away here, like I said, there's two big changes on this chart from the last version of the code, is that's no longer R15, that's R20, and later on we'll talk about the steel studs. But metal buildings, you got the answer, it's R19, and you can see that's the least amount of insulation of any of these. So if you think you were pushing you too hard, look at the rest of the other assemblies. R38 in a flat attic, that's a lot.
With the thermal blocks, is that what you're asking?
Say it again, I'm sorry, I can't hear you.
So,
yeah. In other words, with the insulation having the thermal blocks at the purlins. R10.
Flip my.
Yeah, I don't know what the R10 pertains to. Huh? Yeah, I think it's 6 inches the right answer. I don't know. I'm not sure what that R10. That might have been a mistake. That was all Brandon's fault. If that's a mistake. So now we had that image that I know what you're talking about. It's I think we stole that thing, and it says R10 draped perpendicular to the purlins, R19 running parallel to the purlins, supported by the R10. Oh God, metal buildings. I pull my hair out. To be fair, y'all are like the first class that we've had that's really asked a lot of questions about metal buildings. So I'm sorry we're kind of running around not knowing what we're talking about. But but that's probably in the code. That statement is probably in the code. Huh? Yeah, that's the key. R19 is what they want in essence in the field, if you will, and they want at least R10 at the purlin, so with a thermal block. All right. Does anybody ever have any other questions on roof insulation? We'll review those in a second. Okay, walls, Brandon.
R38, that's 12 inches?
Oh, R38 of, for example, fiberglass, you're probably looking at R30 is probably about 12 inches. So you're looking at more than 12 inches of loose fill fiberglass. You might be able to do it in a bat that's R38, but yeah. It seems like a lot, frankly, but I think what their approach is, look, this is the time in the life of the building to really beef up the roof. You could argue that the roof, there's not much more you can go to make it justifiable to add more insulation in the roof. There's a point of insulation where you add more and more, you hit that point of diminishing returns. It's just not worth it to go any farther. And you could argue that we're definitely there.
But that being said, we're going to show you there's some ways that you can actually reduce these numbers.
Yes.
In the code, there's some provisions having to do with roofs and what kind of roofing material you use that actually will help you reduce that.
So the shiny roofs could get less insulation.
Well, I've seen also with the spray foam insulation on the other side of the deck.
Yeah.
About, after you get 4 or 5 inches.
Yeah, hang on to that. Is that okay? Because that's coming. I've got slides, and we'll definitely talk about it in just a second. So let's just get through this chart. All right, Brandon, we've got walls, and it's listing four types of walls, and metal buildings is just a straight up R13. So that's about 3 inches of that fiberglass. You should have documentation that's going to, or 3.5 inches, I guess, that should tell you that's an R13. Mass walls?
Mass walls are, if you've got block, concrete, brick, what have you, they're asking for you to put an R7.6, essentially an R8, continuous insulation. As Mike was talking about, the steel frame, really sort of recognizing the thermal bridging effect, they are now requiring that you have an R13 plus an R3.8 or an R4 continuous insulation. And that's a big change.
And then wood frame walls, because they don't have quite as bad of a conduction effect as steel, that they only have to have R13 alone in this climate zone. Okay.
I'd also like to point out, we're back to the comment that residential buildings tend to be a little more skin loaded. If you take a look over here on the steel frame, they're actually, instead of an R3.8, they're asking for an R7.5, still an R13, but they're asking for more insulation. Same thing on metal buildings, the same. I guess if you have an interesting metal building, residential. Mass wall R9.5. So wood frame's still the same, but with that you get dinged on the steel and the mass wall.
Any questions on that? So we good on the main thing is everybody understand what's a mass wall, right? Concrete or block or a solid brick wall. What's a metal building? We know what that is. Steel framing, we have to put foam board, and wood framing we don't. So that's this is again the prescriptive code. You can do trade-offs, but this is knowing the prescriptive code.
And I think going back to some of the comments, it was I think there's two ways to do metal buildings. We can have the metal building where you've got the metal sheathing on the outside, the insulation, and then you sort of have a steel stud wall on the interior. That's going to fall under this metal building wall. That exterior sort of component has to hit that R13. But if you move those steel studs out, and those are acting as, your sheathing sits on those as opposed to the purlins, it's going to fall under this steel framed.
Does that make sense, what Brandon just said?
And that's an R13, and the other value is the sheathing.
Correct. Yeah, the R3.8 is the insulated sheathing. It says continuous insulation is what the CI stands for, right? Sorry.
So you had sort of that double wall type thing that we were talking about, sort of metal building, stud wall, or you've just got the metal building and you're infilling in between your steel columns with that metal stud, and that's acting as your exterior wall. That's going to fall under that steel frame. So really sort of two different conditions. You have to consider that.
Did we answer your question? Sorry.
I'm not sure if you did or not. The steel frame where it says R13 plus R3.8, say you have to have two separate insulations or
Yeah.
Not necessarily, though. So you've got, again, you've got this U factor of a 0.84. You actually could do all exterior insulation.
Correct.
If you did all exterior, you'd be looking at what?
No. You could do steel framing with all exterior insulation as long as you hit that U factor.
Yeah.
And you'd get that U factor would, does anybody have a calculator? What is 1 divided by 0.084? That's probably about, what, like a 12 or something? Someone help me. Have
Yes,
mercy on me.
6-inch stud, use 6-inch insulation. You still have the problem. You still have to have the board on the outside.
You're gonna unless you can.
Yes.
The answer is probably yes, unless you can
Unless
get
you can
to
hit that U factor,
U
but you won't be able
factor.
to hit that U factor.
Yeah.
I'm almost positive, because when you do a 6-inch
R12,
wood,
yeah.
6-inch steel stud, 16 on center, you put an R19 bat in it, your effective R value is 7.5.
Yeah, and you need really an effective R value, which is R12.
Yeah,
so if you put an R12 on the outside, it's a true R12 because you don't have that thermal bridging effect. If you start mixing and matching where you've got bat and then some continuous insulation on the outside, you've got to somehow hit that sort of R12.
But you probably would be able to do, for example, what you said, a 2x6 steel studs. You probably could have less than R4 as the continuous
R19,
insulation.
maybe it's an R2
so, yeah,
on the exterior, something like that.
That might get you enough.
Great questions.
These are
Great
very good questions. And what's also good is, remember, this is the prescriptive code, so don't get too depressed about this. You can do trade-offs, but I would really like everybody to walk away with thinking, steel is a great material. There's a lot of good things about it, but if we can get any amount of foam board on the outside of it, that is going to really help our thermal performance. And we'll go into that deeper in a second. Okay, next on the list, a wall below grade is a basement wall. You do not have to insulate that wall in this climate zone. A floor is typically, if you frame it, it's kind of R19, so similar to a residential, or if it's a mass floor, about an R6.
So again, when we're talking about these floors, this is a floor that has a space under it.
Right.
So, maybe
not
you've
a
got
slab on grade.
not a slab on the grade, but maybe you have a crawl space, or maybe it's over a parking deck or something like that. You are going to have to insulate it based upon these values.
So since slabs are very prevalent in commercial buildings, that's the most common foundation we see in a commercial building, right? Right? That's I think almost always the case. So there is no requirement for slab edge insulation in the commercial code, and not until you get into really, really cold climate zones do you have to do any insulation. Because this is something that, it's funny because earlier versions of the code, 10 or 15 years ago, sometimes had slab edge insulation. And people did some wacky, basically worthless things. And one thing that ASHRAE did, which I really like about the way they approach the code, is they try not to just arbitrarily throw things in. They actually analyze, does this save energy? And the answer is that in Augusta, Georgia, slab edge on insulation on a commercial building has a pretty small effect.
And I'd like to add, does it save energy, and is the amount of energy worth the expense?
The expense for the
that
effort.
I've put into it.
Yeah.
So they're actually trying to look at return on investment.
And interestingly enough, if it's a very small commercial building with a slab, the answer is, yeah, it would save probably enough to do it, but it's still not a code requirement. But if it's a big buildings with lots of internal loads, do you appreciate the challenge of how hard it is to make a commercial code that sort of tries to do one size fits all for all commercial buildings? Because think about the differences in commercial buildings. Here we're in an assembly building. There's a fast food restaurant around the corner. There's a hospital or a big data center or an academic building. And those buildings perform, a house of worship. Those buildings perform so differently, and yet we're trying to come up with one answer. It's a challenge. It's hard to make everything fit. But that's what the prescriptive code is basically telling us. So just keep that perspective. And opaque doors have a certain requirement. Does everybody feel reasonably comfortable with how to read this chart and figure out what these numbers are? Because that's my goal, is that you walk away, you could answer a question about that. Let's take a look at some details that, suffer or do well. And we're going to start off with an example. This one's actually not so bad, but this was kind of getting in, George, what you were talking about. So here they're doing vertical insulation, and they are compressing it, but only at the purlins. And I think this is actually a decent assembly right here. So with the metal, in essence, cladding. That's our metal cladding. We do have to be careful about air sealing and things like that, but this can work. Here is maybe, it's a little hard to tell in this picture, but here they're attaching the metal skin directly to the purlins, and then they're putting drywall directly on the inside to the metal studs. And you've got conduction here from the metal skin through the purlin, through the steel stud, through the drywall. The only thing in there that has any R value to speak of is the drywall, and it's a half of an R value. Do you see why that is going to have a problem? Have you ever, this is one that you sometimes see, is what we call zebra striping. Anybody ever seen zebra striping? It's when you go into a commercial building in particular, or a home, I guess, but you see sort of spots of mold growth on a vertical thing that seem to be spaced about every 16 inches, and they're about 1.5 inches wide. And you're like, I wonder what's going on there. And it's because that's a cold surface, right? There's very high conductivity path between the inside and the outside. And so that's what this is basically getting at. So this one on the right is really not going to pass code. I mean, it's not going to pass prescriptive code, and it's not going to work well, I think, is the main thing. George, any comments from you? I'd love to just pick your brain on these. Your wall assembly that you're describing is doing this kind of thing, right, with the insulation behind the skin? Because when you attach the skin right to the metal, that's obviously got conductivity issues. So, questions or comments on this? Are we good on this? Okay. And your assembly that you're describing, I think, from a code standpoint, you get the R value on the outer part. You don't necessarily have to put anything on the studs on the inner part. I think that might be another way to approach it. Or you could go beyond code to say, hey, we're going to work better. Questions, comments? Took a while to get to this picture, but now everyone's dead. No one wants to talk. All right, well, let's talk about just a whole different wall assembly that we actually think is really impressive and seems to perform very well, and that would be ICFs. Has anybody built with these or designed any projects with these? Can you tell us about it?
We did a classroom home in Virginia, and the basement walls were ICF. And so the basement itself was probably just as well insulated as the wood frame building above.
Probably better, in fact.
Yeah.
Yeah. So the ICF technology has been around for a while. Our building that we built in the mid-'90s, in our Southface building, has this in the basement. And our eco office has it. I think that's a picture of it in the upper right. It has it in all the walls, the above-grade walls.
Certainly. And I think, again, you can use a lot of different materials in a lot of different ways. But what's nice about this is it does give you that continuous air, continuous thermal, and moisture barrier. And that's really what we're trying to get to. But yes, you can do this with a metal stud wall. Yes, you can do this with a wood stud wall. You can do this with a mass wall. If there's ways to make your life easier, though, I think we like this technology because of that. So it's interesting. Definitely.
Yeah, and a lot of the rest of the world builds with concrete. And so I think this is one of the best ways to use concrete. There are increased costs associated with this, but you can also kind of green it up by using a lot of high fly ash concrete. Everybody know what fly ash is? Where does the fly ash come from? Does anybody know? A coal burning power plant, right? So it's taking a waste product from a coal burning power plant, and we're actually able to substitute it for cement in the concrete. And cement is very, very, very energy intensive. Making cement is actually a big contributor to the sort of global CO2 production. So if we can displace a lot of that cement with fly ash, that really helps. And so we displaced as much as 40%, I think, in our concrete, which is a pretty high number. If you're in Georgia, chances are you're probably getting 20% anyway. So it's cheaper. It's cheaper. It's a good idea. I like ICFs because they're very strong and because the insulation is continuous. Our system, I think, has an R10 on the outside and R10 on the inside. You get a little bit of R value from the concrete and the air films and all the other stuff. So when it's all said and done, the wall is probably like an R25 with a mass effect. And that greatly exceeds code. And I can say, this is a building you want to be in if something big storm hits or something like that. It's a very structurally sound building. So take a look at it. We actually found, price-wise, it was, back when steel was through the roof. Is steel is it still very expensive? I don't know. It may have gotten cheaper. Steel was going all to China, right? So the demand for steel was very high. This was actually, a couple years ago, pretty cost competitive with steel.